Alright, so today I'm going to go over a more advanced example. So currently I've been giving you problems that only deal with one statement. So let's do a multi-statement problem where you have to actually do a whole bunch of calculations. So for example, let's say that a car started at the 0-meter marker and was traveling at 10 meters per second for 3 seconds. The car then began accelerating at a rate of 2 meters per second squared for 4 seconds. It maintains this speed for 1 second. And lastly, it slams on the brakes, decelerating, that's accelerating, accelerating at negative 20 meters per second squared until it comes to a stop. So I've broken up every sentence and put a number to it. This is more advanced because we're now going to have to look at what happened at certain times. So let's see what we can figure out what happened between steps 1 through 4. A car started at 0 meters mark and was traveling at 10 meters per second for 3 seconds. So for the first part, let's see how far did he go. How far did they travel in step 1 or after step 1? So our initial X starting spot is 0 meters. Or we're traveling at a velocity of 10 meters per second. Does the velocity change throughout it? So that means the final velocity is also 10 meters per second. If the velocity doesn't change, velocity stays still, that means acceleration is 0. And we're trying to find out how far they travel. We're trying to look for delta X. We're solving for delta X. So we know acceleration is 0, we know initial speed, and we know time. We know time is 3 seconds. So we can use the equation delta X equal to initial velocity times t plus 1/2 at squared. Since a is 0, 1/2 times 0 times t squared cancels out, and we're only left with delta X is equal to vi times t Our initial velocity is 10 meters per second times 3 seconds, and that gives us 30 meters. So after step 1, he traveled a distance of 30 meters. All right. For step 2, I should put that or current position or final position is now 30 meters. So how far did the person go during step 2? So now our initial starting location at step 2 is going to be the final position of step 1, right? We're currently now at the 30 meter mark. So during step 1, you're going 10 meters per second for 3 seconds. You start at 0 meter mark, and now we left and made it to 30 meter mark. So in step 2, the car then begins accelerating at a rate of 2 meters per second for 4 seconds. So the acceleration is 2 meters per second squared for step 2, or time is 4 seconds. Is there any other bit of information we can extract? So what's our other variables? VI, VF. What speed are they going at the beginning of step 2? So they started at 10 meters per second, and did it change any? So at the very end, it's still going 10 meters per second. So at the start of part 2, it's still going 10 meters per second. So the initial speed is 10. So here we can figure out the change in x again. Change in x is equal to initial velocity times time plus 1/2 at squared. So here we can plug this in. 10 meters per second. We did this for 4 seconds. Plus 1/2, our acceleration is 2 meters per second squared times 4 seconds squared. Here we can see that our change in x is 56 meters. So if we changed by 56 meters, note that x, so remember that delta x is equal to xf minus xi. If I want to solve for xf, I'd add xi to both sides. So xf would be equal to delta x plus your initial. Or I should write it like this: xi plus your change in x. So we added another 56, so we've added 30. So 56, so it would be 30 meters plus 56 meters. That means our final position is 86 meters at the end of step 2, right? How fast are we going at the end of step 2? So at end of step 2, how fast are we moving? So if we are accelerating, so step 2 says a car then begins accelerating at a rate of 2 meters per second for 4 seconds. So we know our initial velocity was this. We're accelerating for 2, and we do this for 4 seconds. We can use the first equation. Final velocity is equal to initial velocity plus a times t. So we started out going 10 meters per second. We're accelerating for 2 meters per second squared for 4 seconds. So we end up going 18 meters per second. So at the end of this, we're going 18 meters per second. I didn't mean to press that. I'm trying to press something. Yeah. I'll do it later. Alright. So now let's go to step 3. Step 3 says it maintains the speed for 1 second. So for step 3, what we're going to do is look at our old values. So our initial location at the beginning of step 3 will be 86. Our initial velocity would be 18 meters per second because we take what we ended with. We ended at these numbers. So this is what we ended with. So we're going to begin step 3 with 18 meters per second. And now we read the question. It says it maintains the speed. So if it maintains the speed, our acceleration will be 0. And our time will be 1 meter per second. And our time would be 1 second. If it did not change its speed, if your acceleration is 0, or final velocity will be 18 meters per second. 0 acceleration means your speed does not change. So now, how far did it travel after step 3? So again, we can do delta x is equal to vi times t plus 1/2 at squared. Note, because a is 0, we don't have to worry about this. So that'd be 18 meters per second times 1 second. So we changed by 18 meters. To figure out our ending location, xf will be whatever we started with plus or change in x. So we started with 56 meters, or 86 meters, and we added another 18 meters. So that means our final position is 104 meters. Makes sense? So now let's get down to step 4. Lastly, it slams on the brakes and accelerating at negative 20 meters per second squared. So for step 4, we can automatically see that the acceleration will be negative 20 meters per second squared. Until it comes to a stop. We know at the end it's going to go and be traveling at 0 meters per second. So when it comes to a stop, that means that our final speed is going to be 0. Our initial speed is going to be whatever speed we ended at the previous problem. So looking at the previous problem, we stopped where we were going at 18 meters per second. So our initial speed here is going to be 18 meters per second. Our initial position is going to be whatever position we ended up in step 3. So our initial position is 104 meters. So what position did the car reach after step 4? So again, we can apply our equation. Delta x is equal to vi times t plus 1/2 at squared. We plug this in. Vi was 18 meters per second. Our time is... Oh, we're not given a time. So can we use this equation? So we can't use this equation. What do we know? We know acceleration, we know vi, ref, we know vi, and we know xi. These are going to be our primary, and we're looking for delta x. We need to change. So, which equation will we use? We use the fourth one. Vf squared equals vi squared plus 2a delta x. We're solving for delta x. So subtract this over. Vf squared minus vi squared is equal to 2a delta x. Now divide by 2a. 2a to both sides. Just cancel out 2 and the a. And we see that delta x is equal to vf squared minus vi squared divided by 2a. So 0 meters per second squared is our vf, minus our vi was 18 meters squared, the whole thing squared, times 2 times negative 20 meters per second squared. If you plug that into the calculator, you'd see that it stopped in 8.1 meters. And to figure out our final position would be whatever we started with, our initial position, plus our change in x. So that would be 104 meters plus 8.1 meters, which will give us 112.1 meters. Alright. So, this is how will we solve a multi-step problem? So, so let's go back over it. A car started at 0 meters, the 0 meter marker, and was traveling at 10 meters per second for 3 seconds. So it did this between marker 0 and marker 30. So between 0 meters, so if I were to draw this out, so if I were to, so it started at 0 meters and it ended at 30 meters. Between this, it was traveling at 10 meters per second for 3 seconds. Step 2, the car begins accelerating at a rate of 2 meters per second for 4 seconds. So, beginning at the 30 meter mark, up into the 86 meter mark, so between 30 and 86 meters, it was accelerating for 2 meters per second for 4 seconds. Number 3, it maintains the speed for 1 second. So it reached a speed of 18 meters per second. So its speed was 18 meters per second. And between 86 and 104, so between 86 and 104 meters, it maintained a speed of 18 meters per second for 1 second. And then lastly, what it did was it slammed on the brakes, accelerating at negative 20 meters per second squared, and eventually reached a distance of 104. Not 104, 112.1. So 112.1 meters. We could also, for step 4, if I wanted to, we can figure out how much time it took. So for step 4, I'll let you finish writing it down if you want. Let me print one more thing. My computer is so slow. I have too much things open. Alright. So for problem 4, we can also say how long did it take to come to a stop. We can solve for time. So we have various equations. So let's use the simplest one. VF equals VI plus A times T. We're solving for T, so we subtract VF, or VI I mean. So it's VF minus VI is equal to A times T. Still solving for T, so we need to divide by A. Divide both sides by A. A cancels out on this one. So we're left with T equal to this. So T is equal to VF minus VI divided by A. So our final was 0 meters per second. Our initial was 18 meters per second. And we're accelerating at negative 20 meters per second squared. So it took us 0.9 seconds. So here it took us 0.9 seconds. Nicole, would you go to the teacher's room and pick up the homework? There should be 3 copies of each. Does that make sense? So it takes a lot of math to get this, but that's what physics is based on, is trying to figure out what's going on over the entire problem. So this is multi-layered because the car isn't keeping the same amount of acceleration. The acceleration is changing. In steps 1 and 2, it's constant. In step 2, he's accelerating and speeding up. In step 4, he's braking and slowing down. But we can figure out everywhere in that journey what's going on. What his speed was at the beginning, what his speed was at the end, where he was, and what he was doing at every point. So just basing on a few key facts, we're able to extract all the information from it. Let's see another example. So one of the favorite things I like talking about is guns. So suppose a bullet. Yeah, you can pass them both out. I'm giving y'all 2 homeworks. The second one, homework 2, is just algebra. Homework 3 is more problems like this. So in homework 2 just requires you to do the algebra. So a bullet leaves the muzzle at a rate of 500 meters per second. The length of the barrel is practices will stay in effect as normal for the rest of this week through the weekend. Their practices will be canceled. Will remain Monday. We will return back to normal schedule. So a bullet leaves the muzzle of a gun at a rate of 500 meters per second. The length of the barrel is 0.45 meters. So there's a lot of information hidden in this statement. Doesn't seem that much. All we know is the speed of the bullet after it's left the gun. We know how long the barrel of the gun is, but we can extract a lot of information from this. So for one, what is the acceleration of the bullet? So what is the acceleration of the bullet? We will learn later in the year that we can take acceleration and determine force. But for now, we're just looking at acceleration. What is the acceleration of the bullet? And as I said, this is why it's important to make sure you get this down, because we will be using this throughout the year. So we know that the final, first of all, what's the initial speed of the bullet? I said initial. What did it start out with? Yes. So before you actually fire the bullet, it's not moving. At the end of its journey, it is moving 500 meters per second. We know that it changed its spot. Again, we don't care how many miles or meters away from Houston it is. We know that it changed its position. Its displacement is 0.45 meters. It started at one end of the barrel and went to the other side. That's all we're concerned with. But we got 3 known variables. That means we can solve for all the other ones. The first question is, what is acceleration? So Vf is equal to Vi plus A times T. We don't know anything about time, so we can't use that one. So we can't use this equation. If you look at the last equation, Vf squared is equal to Vi squared plus 2A delta x. We know delta x, we know Vi, we know Vf, we don't know A. So we can use this equation. Again, we subtract Vi squared from both sides. We move this over to the left by subtracting. And then we divide by 2 delta x. 2's cancel out on this side, delta x's cancel out on this side. So we're left with A equals Vf squared minus Vi squared divided by 2 delta x. So our final was 500 meters per second, the whole thing squared, minus our initial was 0, so we can leave that off, times 2 times 0.45 meters. And we get that the acceleration of the bullet is 277,778 meters per second squared. That bullet undergoes a tremendous amount of acceleration. It is changing its speed. It's going from not moving to moving at very great speed very, very quickly. Imagine the time it takes to actually go from not moving to leaving the barrel. It's faster than a blink of an eye. Which is what the next step is. How long does it spend in the barrel? How long does it take to travel the length of the barrel? So when you fire a gun, how long does that bullet actually stay in there? So again, we have all these variables. So we know its initial speed is 0 meters per second. We know its final speed is 500 meters per second. We know that it changed its position by 0.5 meters. We know that the acceleration is 277,778 meters per second squared. And what we're looking for is time. Now, you can use this equation. Delta x equals Vi t plus 1/2 AT squared. We have A, we have Vi, we have delta x. However, we have 2 t's. We have a t here, t here. This means we have to use the quadratic equation. The quadratic equation is long and complicated. I would not use this equation. Let's look at another equation. We have Vf equals Vi plus At. This equation is much simpler. We can use this equation instead. So solving for t, we get VF minus VI is equal to A times T. Again, solving for T, now we divide by A. A's cancel out, so T is equal to VF minus VI over A. So that'd be 500 meters per second minus 0 meters per second over 277,778 meters per second squared. And we see that the bullet only was in the barrel for 0.0018 seconds. A fraction of a second. Now, that wasn't the only equation we could have used. We could have also used the other equation. What was the other equation? What's the third equation? So we can solve for t. So solving for t, if we have some fraction multiplied to a variable, what we can do is multiply by the inverse. So 2 divided by VI plus VF, the reciprocal. You can multiply both sides by the reciprocal to cancel it out. VI plus VF. So this times the reciprocal cancels each other out. And we're left with only t, so t equals 2 delta x divided by vi plus vf. So 2 times 0.45 meters divided by 500 meters plus seconds plus 0. I've written it backwards. Anyway, the 0 cancels out. VF plus 0 is just 500. And if you work this out, you also see it's equal to 0.0018 seconds. So you're not limited. You could also use the quadratic formula. You aren't limited with the equation you select. As long as you know 3 variables, so we knew VI, VF, and delta T, we can solve for the fourth. Here we knew VF, VI, and A, we can solve for the fourth. Here we know delta X, VI, and A. We can solve for T, but since there's 2 T's, we would have to use the quadratic equation. So any questions? Does this seem easy? Alright, that's it for the day. Tomorrow, basically I've already assigned you the homework for tomorrow. Neither one of y'all have turned in homework 1 yet. All finished?